Hi there, so we're going to go over elementary statistics. This is Elementary Statistics by Mario F. Triola, the 8th edition. And really we're going to start with Chapter 5, and we're going to do Chapter 5, Section 1. And this is essentially about normal bell curves and normal distribution. And as you see, this is just a normal shape of a bell curve. And that's what we're visually going to use. You don't really need to worry about it that much, but that's basically what it is. And this is just information. There's a whole example of like what it means, but just memorize it. 1 standard deviation equals 68%, and 2 standard deviations equals 95%. And this is considered normal standard deviation, so normal deviation. And then a calculator is, there's a way to solve these algebraically, but it is so much work. So you really need a scientific calculator, and I'm going to do it from a calculator point of view, so comment below if you need the algebraic information, or look in your textbook, or whatever textbook you're using, not necessarily the Mario Triola one. Okay, so let's get started. We're going to do the first example, and this is my first example. You just get a student took a bunch of different prices from 100 people in a survey and found that the mean amount of money someone spent on a pair of jeans was $45.99 with a standard deviation of 13.26. And you're just going to use that for that problem. So here's how you make your normal bell curve. You do the general shape, and then you have your mean in the middle directly. And then we did 1 standard deviation, so adding that 13.26 and subtracting that 13.26. So, oh, I'm so sorry, I wrote 59.25 twice. That should actually say 32.73. Sorry about that. That is totally my mistake. Anyway, so you have your mean, and you're going to subtract 13.26 from it, and you're going to get 32.73, and then you're going to add, and that's your first standard deviation. So that's just one time did you add that standard deviation. So that's your first one. And then you're going to do it again. And for now, that's all you're going to do. Just the first two. So you take this number, add 13.26, get that, and subtract 13.26 from this number, and you get those. So that's all you need for this particular problem. So the first question we're going to ask is, what's the probability that one student spent between 32.73 and 59.25? And so you're going to look back up here. We did this first standard deviation. There's 32.73. There's 59.25. That's what the question asks for. 1 standard deviation, looking back up here, is 68%. So that's the probability. Simple as that. So we're going to go into question 2, and this one's a little bit harder. What is the probability that one student spent between $45.99 and 59.25? So you're going to go back to this chart, and you're going to see, okay, the mean is 45.99. And you have the added 13.26 of 59.25. So looking at this, you know that 1 standard deviation is 68%. This entire thing is 68%, and the mean splits it in half. So you can just assume that 1/2 of 1 standard deviation, so 1/2 of 68%, is about 34%. So that's your answer, 34% likely. And that is normal bell curve. So let's continue on. Now you're going to learn about z-scores. And so we're going to go back to that same bell curve, which I rewrote here, with its mean of 45.99 and its standard deviation of 13.26. So we're given the question, what is the probability that one student will spent more than $85.77? So you know this is higher than the 2 standard deviation. And, oh my gosh, the cat just knocked that over. Sorry. Stop. Should not even let him in here. Okay, so you know it's going to be higher than 2 standard deviations, which means it's going to be a smaller number. So you're going to pull out your calculator, and you only need a TI-83 or more, but I'm going to show you the TI-83 Plus because that's what I have on me. Okay, so here are my Texas Instruments 83 Plus. I'm going to open that up, and you're going to see this, obviously. So you have to turn it on, Okay, so on your TI-83, you're going to hit second, and this VARS, which takes you to distribution. And then you're going to see the screen, and all you do is go down to number 2, normal CDF, and obviously hit enter. So now you're going to see this. It has a parenthesis set up for you, and you just have to close it at the end. So what you're going to put in is, and this is how you write it correctly, normal CDF, parentheses, and you're going to put the 85.77, which is your smallest number, and you're looking for everything over 85.77. So you're going to go to your calculator, and you're going to put 85.77, comma, okay? And then you need a really big number, so you're going to put a bunch of 9s, and just as many 9s as you want. I wouldn't go too crazy, but you can't just leave it at like 4, you need like that many, just to be safe, comma, and your calculator will know that you mean basically infinity. So then you put in the mean and the standard deviation. So you're going to put in 45.99, comma, and then you're going to put in 13.26. And this time you're going to close the parentheses, which is right above the 9, and then you hit, sorry, doing this one-handed. Then, so you have all those numbers, and you hit enter, and it gives you the answer, 0.001349. So you can write that 0.00135, whatever, but I just leave it as approximately 0.0013. And this is how you would write it in your notebook. Normal CDF, 85.77, big number, a bunch of 9s, or 9 infinity, 45.99, 13.26, and 0.0013 is the answer. And that is how you do z-scores for a normal bell curve. We're going to continue on to 5.2, which is normal probability distribution. And in this example, we have this normal bell curve, and the mean of women's height is 63.6 inches with a standard deviation of 2.5 inches. So we're going to find this one right here, and that's just a visual example. The question is, to join the Beanstalk Club, you have to be 70 inches or 5'10" or taller for women. What is the percentage of women eligible to join this club? So you already learned that in 5.1. You take normal CDF on your calculator, you would type in 70, a big number of 9s, 63.6, and 2.5. And this would equal approximately 0.0052. So about 0.5%. Okay. So now we're going to go into not just big numbers. We're going to use normal CDF in different ways. Here we're given the question, what is the percentage of women 64.5 inches tall to 72 inches tall? So both of these are obviously over the median height of 63.6. So you know it's probably not going to be a hugely high number, but it's still going to be larger. So you're going to take this and you're going to do it exactly like the other one. You just won't have a large number. You have normal CDF, and you're going to have the smaller number of 64.5, then the larger number of 72. So the calculator will only do what's between 64.5 and 72. So we're setting its limits again. And then you do the same of the mean, 63.6, and the standard deviation of 2.5. And once you use on the calculator, it'll equal about 0.3590 or 0.36, which equals 36% women. So like I said, it would probably be a little bit of a larger number, although not half. And that's how you do it if you have set limits. It's really simple in my opinion. So now we're going to do a problem that is smaller. So you did one that's greater, which had you, the smallest was a set limit number, and then you had a large number of mini 9s. We're going to do the exact opposite of that. Excuse me. Okay, so you have a mean, you're looking at sugar packets, and you have a mean of 3.586 grams with a standard deviation of 0.074 grams. So the question asks, what percentage is 3.5 grams or less? So you have your mean here, and you want to find 3.5 or less, infinity less. So you're going to take your calculator out, and you're going to do normal CDF. So I'll show that for you. So you're going to turn it on, of course, and you're going to go to your second vars, and you're going to go down to normal CDF. But this time, you're going to do a very large negative number. So here you have this, and you're going to do negative, you can see right here, and you're going to do a bunch of 9s. And this is going to be your smallest number. And this one has to go first because it's the smallest infinity instead of largest infinity. And then you're going to type in your 3.5, which is your highest number because you're not going over 3.5. So you'll type in 3.5, comma, and then you're just going to do the mean and standard deviation like always. So you're going to type in here 3.586, comma, and then 0.074, and you're going to close that and hit enter, of course. And you're going to get about 0.12258 or 1.1226, which really just rounds to 12%. And that's your answer. So I find the z-scores to be relatively simple as long as you remember that if it says or less, you're going to do the negative, and if it gives you a number or greater, you're going to do, for example, say this said percentage of 3.6 or greater, right? So instead you would have here 3.6 and all of this to infinity. And so instead of the -9, you would have normal CDF, the 3.6, comma, 999, etc., comma, 3.586, comma, 0.074, and then you'd get your answer. So I think you could easily tell what the difference is, that if you have a greater, you put small number, because you're going greater. So small number, it's always small number first and greater number second. So here we have small number because it's infinity small because of this negative, and then the biggest number here, greatest number, then mean and standard deviation. And that's always how it's going to go for normal CDF or normal bell curve. Okay, so we're going to finish with 5.4, which is finding values. And how you have addition, subtraction, multiplication, division, powers, and roots. The opposite of probability is called the inverse normal probability distribution, or the inverse norm. And the way you find this on a calculator is you go second vars, and you choose inverse norm, which is number 3. So I can show you on the calculator, but I'm going to go into greater detail in a second. But basically, like I said, second vars, and you have all these ones, and that's where you have the normal PDF. You just go one under the normal CDF, and you choose 3, inverse norm, and then you're going to type in different numbers. And the 3 numbers you're going to type in are the area to the left, which you'll get in a second, the mean, and the standard deviation. So it's really easy. The only one you have to find that's usually not given to you is the first number you type in, which is area to the left. So let's find out what I'm talking about. So here's our first example, and we're going to use that gene problem again, where the mean was 45.99 and the standard deviation was 13.26. So you have your normal bell curve, and you have the left of the mean and the right of the mean. And that's not really important. I'm just showing, obviously that's the left side and that's the right side. So this question asks what price, and it could be anything in this, it's not only for price, obviously, so that's why I underlined it. But anyway, what price is the bottom 1%? So you really want to know what number here would be the cutoff for where it's 1% of the entire 100%. So you really want to find what price is that. So how you do that is really easy. You go to inverse norm, and we'll show it on a calculator. So again, you do second vars, and you go down to 3, inverse norm. And the 3 numbers you're going to type in is what's to the left. Well, here you have your box. What's to the left? 1%. How do you type that in? 0.01, comma. And that's it. And we'll give you another example in the next video, but that's all you do. Then you do the mean and standard deviation. Okay, and then you type it all in, hit enter, and you get your answer, 15.14, or about $15.14.